Hello everyone, myself Madhvi Gaur. In today's lecture, I am going to discuss about Q. Let us start our introduction. A queue is a linear data structure. It is basically a linear list of elements in which insertion and deletion can take place from different ends. The point to be noted here is that we can do the insertion and deletion, but it can be done from the different ends. Okay? Insertion can take place from the rear end, whereas deletion can take place from front end. Just in contrast with stack, in which the insertion and deletion can be done only from the top. This is the layout of the stack in which the insertion and deletion of the elements can be done from the top only. Whereas in case of queue, it follows the first in first out policy. It means the element which enters first into the queue will be the first element which will come out of the queue. Whereas stack follows last in first out, our queue follows first in first out. That is the element which comes first, that will be served first, or that will leave the queue first. These are certain real life applications of the queue. People waiting in a line at a bank, jobs on a printer, railways reservation. It means if we are going to a bank for certain work, then we have to maintain a line. First of all, we have to maintain a line. Then the person sitting at the counter will entertain the person which is at the first position in that line. And that will be served first. It means that person will leave the queue first. That's why it follows the first in, first out policy. Similarly, for the jobs on a printer and for the ticket counter at a railway reservation. Let us see the queue representation. As we know, queue is a linear list of elements. Let us see through this diagram. There are 6 memory cells. Okay. And let us assume there are few elements 10, 20, 30, 40, 50, and 60. These elements needs to be inserted inside this queue. As we know, the insertion and deletion can be done from both ends, but from different ends. But from different ends. It means if we want to do the insertion, then it can be done from the front end only. And if we want to do the deletion, for insertion, it can be done from the rear end. And for deletion, it can be done from the front end. Okay, let us see through this example. Initially, front is at position -1 and rear end is also at position -1. If we want to do a insertion, first time insertion, then front needs to be updated as 0 position and rear also needs to do at the 0 position. Then if we want to insert 10, then front and rear, both pointer will point here. Okay. If we want to insert another element 20, then we have to do rear is equals to rear plus 1. It means now rear will point here and we can do the insertion of 20. Similarly for 30, rear will point here. For 40, 50, 60, at the end, rear will point here. At the same time, if I want to delete element from the list, okay, then front needs to be updated by 1. It means the element which comes at the first, it will be deleted first from the queue. It means 10 will be deleted from the queue and front will be pointed here. Similarly, if we want to do another deletion operation, then 20 will be deleted from the queue and front will point here. After deleting 30, front will point here. After deleting 40, front will point here. After deleting 50, front will point here. So after performing all these operations, now front is pointing to 5th position. Similarly, rear is also pointing to 5th position. Okay. Let us consider some another example where we have a memory cells of 6 elements. We are allocating the memory spaces to all these locations. Initial memory position is blank. Then there is L, P, R, T. This is the initial setup of a queue. Okay. And front is pointing here as per the given example. And rear is pointing here. Okay. And we have to perform all these operations. After performing all these operations, we have to tell where is front and where is rear pointing to. Okay. Let us consider the first operation, A. Let's go to another slide and we will do all these operations there. Front is here and rear is here. First operation which needs to be performed is A is added. So for performing any operation, rear and needs to be updated by 1. It means rear should be shifted to rear plus 1. And we have to add A. Next operation to be performed is 2 characters are deleted. As we know, deletion can take place only from the front end. So we have to delete 2 characters. It means we have to delete L and we have to delete B. Then front will point here. Next operation is M is added. As we know, we have occupied our 5th position because we have only 6 memory cells. Then no new member can be added. It means we cannot add M inside this queue. So on addition of M, it will show or it will give us a message overflow. Overflow means we cannot insert new element inside this queue right now, as we do not have another memory space. Even though we have vacant memory spaces, but we cannot perform insertion over that. Okay. Next element is O is added. Similarly for O also, it will return overflow. Next, 3 characters are deleted. 3 characters will be R, P, A. All these elements are deleted. Now, front will point to -1 as we have deleted all the elements R, P and A. As we know, if there are no elements inside this Q, then front is also at -1 and rear is also on -1 position. Okay? Then Q is added. Initially, RQ is blank right now. Front is at -1. Rear is also at -1 position. And we want to do the insertion of Q. So for inserting any element, we have to first do front is equals to 0 as well as rear is equals to 0. Only then we can insert new element, which is Q. Now, front is pointing at 0 location, rear is also at rear position. Okay. So after performing all these operations, the question is asking front and rear position. Okay. Then after performing all these operations, now front latest position is 0 as well as rear position is 0. Because there is only one element inside a Q. Whenever there will be a one element inside a Q, front and rear always point to same location. Whenever there will be only one element, which will be 0, 0th position. Okay. As we know, we can perform two operations on Q, insertion and deletion. Let us see the pseudocode of Q insertion. These elements will be given to us. Q, number of elements, front end, position, rear end, item. Which item needs to be inserted inside a Q. Okay. We have explained all these concepts through the last example. Now we will see the pseudocode of it. Okay. If front is equals to 0 and rear is equals to n-1 position, then we cannot insert the new element. In that case, our procedure will give us overflow and it will return. And it will return this value because we cannot insert new element right now. If front is equals to -1, initially it means there is no element inside the Q. No element inside a Q. So whenever there is no element inside a Q, then front and rear will always point to -1. Then for inserting a new element, we have to set front is equals to 0 and rear is equals to 0. In this case, Q is full. Whenever Q is full, it will return overflow. But if these two cases are not there and we want to insert a new element, then we have to do rear is equals to rear plus 1. Then after performing the increment inside the rear position, now we can insert our new element, which is Q of rear item. Now we can place the item at this position where rear is pointing. Okay. Next one is Q deletion operation. As with the last case, there will be these elements Q, N, front, rear, item, all these positions and items value we will know in advance. Then if initially front is pointing at -1 position, rear is also pointing at minus position, it means there is nothing to delete. Front is at -1 and rear is also at -1. In that case, the Q is empty. It means there is no element to be deleted. Then in that case, this procedure will return underflow as RQ is blank or empty. Okay, let us consider the another case. In this case, RQ is empty. Let us consider the second case. If front is equals to rear, as in the last example, I have already explained it to you. If there is only one element inside a Q, let us consider front is also pointing here and rear is also pointing here. It means there is only one element inside a Q and we want to delete it. There is one element only and we want to delete it. Then we have to set front is equals to -1 and rear is equals to -1, as there is no other element to be deleted. If there is no other element to be deleted, then we have to set the locations of front and rear as -1. If these two cases are not there, it means there are few more elements which can be deleted from the queue. Let us assume front is here and rear is here. In this case, if we want to delete 10, then we have to set front is equals to front plus 1. In this case, this step will be executed. Okay, so this is all about the queue concept, including the insertion operation, including the deletion operation. It always follows the first in, first out policy or first come, first serve. We have already discussed the real life applications of queue. This is the reference which I have considered for preparing this PPT. Okay, thank you everyone.